Hello, welcome Shikhabroti. I am Tanmay Paul and today I will discuss about a beautiful topic of mathematics is logarithm. So first we see the spelling of logarithm, that is here we divide this word in two parts. One is log and one is arithmetic. Arithmetic means arithmetic, that means mathematical calculation, and log means rule. So logarithm is a subject where we discuss about a mathematical operation rule, and it will help us to solve a very difficult problem in arithmetic. First, we have to know that any positive integer can be expressed in two ways. One is exponential form and second is logarithm form. That is, here any number integer greater than 0 is exponential and logarithm. If we write 36, then it can be written as 6 square. So this is our integer. 6 is called base and 2 is called power or index or exponent. Now if we express 36 in logarithm method, then we write this 36, that's equals to 6 square, and that's equals to log 2 base 6. Sorry, then we can write this as log 6 base 36 equals to 2, and this is the logarithm representation of 36. So if we choose any number a, that's power x equals to m, then logarithm defines x equals to log a m. Here a is the base, m is the number or integer, and x is the power or exponent. Now there is a condition for a or base, that is a greater than 0 but a not equals to 1. This is the condition for base of logarithm. And why we use logarithm? In some cases we cannot find power in normal integer, then we use logarithm. Now to an example, if we write 20 is equal to 2 to the power x, then we cannot find the value of x in general. So in this case we use the logarithm. So in this case we can write x equals to log base 2 20. So this is the main purpose of logarithm. to find such value which cannot be determined easily. Nowadays you can use a calculator to calculate this value easily. So we can write a to the power x equals to m, that x equals to log a m, and this is the basic of log. Now we discuss some example. If 2 to the power 6 equals to 64, then we can write it as log, this is in the base 2, and 64, that's equal to power 6. So if this is the power and this is the base, then it also gives it and converts also true. Similarly, if we write 3 to the power minus 4, that means 1 by 3 to the power 4, that is equals to 1 by 81. If we express it through log, then we write log, base is here 3, the number 1 by 81 here, equals to minus 4. And for again in another example, 10 to the power minus 2, that's equals to 1 by 10 square, equals to 1 by 100. Then in log it can be written as log base 10, so 10, the number 1 by 100, and that's equals to power minus 2. Now we discuss some point about log. If a to the power x equals to minus m, then there is no real value of x. So here x is imaginary. Now choose a number x which is not equals to 0, but x to the power 0 equals to 1. So in the logarithm expression we can write 0 equals to log x1. So for any base, if the number is 1, then the logarithm value is always 0. Take another example. If 2 to the power 0 equals to 1, then 0 equals to log 2 1. That means if we take power 0 of 2, then we get 1. So log base 2 of the number 1 is 0. And similarly, if we take a number 2, to the power 1, that's equals to 2. This is the exponential expression of 2. And if we express at logarithm form, then we can write 1 is equal to log 2 base 2. So if the base and the number is same, then the value is always 1. So here we can write log a that's equals to 1, where a not equals to 1, because in the previous case we see that if the number is 1, then the value is 0. So this is our again a rule for logarithm. Now go to some general laws of logarithm. First, log a m n, that's equals to log a m plus log a n. Now we prove this. Here we take log a m, that's equals to x. So a to the power x is equal to m, and similarly log a n equals to y, then a to the power y equals to n, and if we multiply this, we get a to the power x into a to the power y, that's equals to mn. So a to the power x plus y equals to mn, and if we take log, then we get x plus y equals to log a m n. So here x equals to log a m and y is equal to log a n. So we prove this laws, that is log a m n equals to log m base a plus log n base a. Now go for the second law, that is division rule. Log a m by n equals to log m minus, and we solve this as we previously do. Here we take log a m equals to x, that implies a to the power x equals to m, and similarly log a n equals to y, implies a to the power y equals to n. Now if we divide this, a to the power x by a to the power y equals to m by n. It implies a to the power x minus y equals to m by n. Now x minus y equals to log base a m by n. Here x is log m base a and y means log n base a. So our laws are proved. So today's class is finished, and we discuss and some other formulas for the next class, at the next class.